based on the quartiles, quartile 1, quartile 2, quartile 3. So any distribution, so we define quartile as any distribution if any distribution is divided into 4 equal parts. Divided into 4 equal parts. Any distribution which is divided into 4 equal parts. So then there will be the 3 quartiles. So then there will be 3 quartiles. Any distribution divided into 4 equal parts, so there will be 3 quartiles. We denoted as quartile 1, quartile 2, and quartile 3. So the quartile 2 is itself median. So we need is itself median. Okay, so hence we need to determine quartile 1, quartile 2. So quartile 1 is known as the lower quartile and quartile 3 is called the upper quartile. So quartile 1 is known as the lower quartile, and quartile 3 is known as upper quartile. Okay, so for calculating the quartile, that means we start with measuring of we also include here a decile, and we decile. Second, we use decile. Decile means if any series or distribution divided into 10 equal parts. If any series or distribution divided into 10 equal parts. Divided into 10 equal parts. Divided into 10 equal parts. So then there will be 9 deciles. 9 deciles. There will be 9 deciles. We denoted as D1, D2, D3, and so on D9, up to D9. So this is for decile. And talk about the percentile. Last one is percentile. So in case of percentile, so a distribution divided into 100 equal parts. So then there will be 99 percentiles. Will be 99 percentiles. So we denote these percentiles as P1, P2, P3, P1, P2, P3 and so on up to P99. P99. So for this case, that means up to P99. So the P50 here, the P50, 50th percentile, P50 is as median. P50 is median, and P25, P50 is median, P25 and P75. P25 and P75 be the lower quartile and upper quartile. Be the lower quartile and upper quartile. Lower quartile and upper quartile. Lower quartile and upper quartile. So P25 and P75 be the lower and upper quartile, and P50 is the median. So now we calculate these all. So by using the formula, that means first we write as measure, we construct a table. Second, we use a individual series, individual and discrete. Individual and discrete. And second is continuous series. And a formula for continuous series. Formula for continuous series. So we write the formula for continuous series. So if we calculate quartile 1, so we basically start with quartile 1. So when we calculate quartile 1, so just you find n plus 1 by 4th item. N plus 1 by 4th item. This is for individual series, that means quartile 1, n plus 1 by 4th item. For individual series, n number of terms, discrete series, summation of f is used as n. Remember. Second, for a continuous series, we calculate n by 4 item. N by 4th item. N by 4th item. And what is the formula for calculating quartile 1 for continuous series? So same, L1 plus n by 4 minus c over f into L2 minus L1 into L2 minus L1. When we calculate median, so we have the formula n by 2. But in case of quartile 1, we just divide by 4. N by 4 minus c over f into L2 minus L1. And for calculating quartile 2 means median. So we have the median formula. So for quartile 3, so calculating quartile 3, that means we write as 3 into n plus 1 by 4th item. 3 into n plus 1 by 4th item. Here is 3n upon 4th item. And we calculate quartile 3. So by using the formula L1 plus 3n upon 4 minus c over f into L2 minus L1. So this is for quartile 3. All you noted? Okay, very good. Very good. So now next. we write for decile. So how to calculate decile d1? So while calculating d1, so we use the formula, that means n plus 1 upon 10, n plus 1 upon 10th item, n plus 1 upon 10th item. Here is n upon 10th item, n upon 10th item, and for calculating decile 1 for continuous series, we write as L1 plus n upon 10 minus c over f into L2 minus L1 into L2 minus L1. So this is for decile 1. Similarly, you for decile 2, that means taking d2. So d2 is 2n plus 1 upon 10, and d3. So we write d3. You can for d3, 3n plus 1 upon 10th item. Here 3 upon 10th item, and calculate d3, L1 plus 3n upon 10 minus c over f into L2 minus L1 into L2 minus L1. So this is for d3. Similarly, you can write for d5, d7, d9. So multiply by 9 when you calculate d9. So I'm writing directly, that means writing d9. So you can write general case. So 9 into n plus 1 upon 10th item, and 9 by 10th item, and you can calculate d9, L1 plus 9n upon 10 minus c over f, L2 minus L1. So this is for decile. And the last we write as percentile. So for calculating percentile, P1 equal to n plus 1 upon 100, n plus 1 upon 100th item, n plus 1 upon 100th item, here n upon 100th item, and for calculating percentile 1, so we write as L1 plus n upon 100 minus c over f into L2 minus L1. So similarly, you can write for P99. So I am writing P99 last. So you can make formula for others, that be P2, P3, P4. So I'm writing like P99. So we can write as 99 into n plus 1 upon 100th item. And this is 99 n upon 100th item, and P99 is equal to L1 plus 99 n upon 100 minus c over f into L2 minus L1. So these are the formula you have to remember we can solve the problems directly. So that means while calculating Bowley's coefficient of skewness, so just you remember the formula. Okay. So we take the problems related to the Bowley's coefficient of skewness. Now, question related to Bowley's coefficient of skewness. Related to Bowley's coefficient of skewness. From the data, calculate coefficient of skewness. Data is given as marks. So 5, 15, 25, 35, 45, 55, and number of students. 10, 20, 30, 50, 40, and 30. So we need a cumulative frequency for this also. So we make 3 columns. First column is X, denoted as X, that is marks, and second number of students, denoted as frequency, and the third we calculate the cumulative frequency. So 5, 15, 25, 35, 45, and 55. Frequency 10, 20, 30, 50, 40, and 30. Cumulative frequency 10, 30, 60, 110, 150, and 180. So this is the cumulative frequency. Now we need to calculate summation of f, sum of all the frequencies, which will be 180. We calculate quartile 1. So quartile 1, we write the formula, that means size of, because this is the discrete series, so we use the same formula for discrete and individual. So size of n plus 1 by 4th item. Size of n plus 1 by 4th item. So this means size of n. Here n belongs to the summation of f. So because this is the discrete series, so we write as 181. 181 upon 4th item. So 181 upon 4th item. So that means we write as size of 181 upon 4th. So 4 4 is 16. 16 to 20. That means 4 5 is 20 and 0.25. So 45.25 item. We see that this item 45.2th item fall in which cumulative frequency? Fall in 60th frequency. So falls in this frequency. In front of this frequency, what is the value of x? So the value of x is 25. So this means that quartile 1 is 25. So quartile 1 quartile 1 is equal to 25. Quartile 1 is equal to 25. Now we calculate quartile 2. That means median. So because we need a median also, so how to calculate quartile 2? Calculate what is the value of median. So we calculate median. Median also known as quartile 2. So we just take the value, that means n plus 1 by 2th item. N plus 1 by 2th item. This is for median. So that means size of 181 upon 2th item. 181 upon 2th item. So this equal to, we write as size of 90.5th item. So size of 90.5th item, this 90.5th item fall in this cumulative frequency. So in front of this, so this is the median. This is the median, this is the quartile 1. So the median, median is equal to 35. Median is equal to 35. Now calculate quartile 3. Quartile 3, so 3 into n plus 1 by 4th item. That means size of n plus 3n plus 1 by 4th item. So this equal to, we write as size of 3n. 3, so n is 180, so 181 upon 4th item. 1 upon 4th item. So this equal to size of 3, 181 upon 4, we calculate above, that means 45.25. So 25 item. So this will be size of 135, yeah, 135.75. So 135.75th item, yeah. So this 135.75 item fall in which cumulative frequency? Falls in this frequency. So here 137.75. So falls in this frequency. So in front of this frequency, that in front of 150, that means value of x is 45. So this will be the quartile 3. So value of Q3 is 45. So quartile 3 is 45. Quartile 3 is 45. So we have the value of quartile 1, quartile 3 and median. So we write the formula. Bowley's coefficient of skewness is equal to, what is the formula? 1.75. Okay, very good. So formula is quartile 3 plus quartile 1 minus median upon quartile 3 minus quartile 1. So this will be 45 plus 25 minus median, twice of median. Here is twice median. Just this is for 2 median. Twice of median, because we see that median, so twice of median and quartile. So change the formula, Q3 plus Q1 minus 2 median upon Q3 minus Q. Yes. So 2 into Median is 35. So median is 35 upon 45 minus 25. So 0. 0, so that means no skewness. No skewness, symmetrical distribution. No skewness, symmetrical distribution. So this is for Bowley's. Okay, you can solve the problems related to continuous series. Similarly, we have all the formula. Now we move to the next method, which is the Kelly's coefficient of skewness. So next is Kelly's coefficient of skewness. We solve more problem related in tutorials. So next method is Kelly's coefficient of skewness. Kelly's coefficient of skewness. Kelly's coefficient of skewness. So this Kelly's coefficient of skewness is the modified method. So Kelly modified the Bowley's coefficient. Kelly modified the Bowley's coefficient of skewness by taking any two deciles. By taking any two deciles equidistant from the median or any two percentiles. Any two percentiles equidistant from the median. So on the basis of decile or percentile, you can solve the Kelly's coefficient of skewness. So that means Kelly's coefficient of skewness we can calculate on the basis of percentile P10 plus P90 minus twice of P50 upon P90 minus P10. Same formula, that means quartile 1 plus quartile 3 minus twice of median upon Q3 minus Q1. So here is percentile case. So P10 plus P90, and for second case of decile, so here D1 plus D9, D1 plus D9 minus twice of median upon D9 minus D1, so minus D1. So we talk about the median. Median means percentile of 50 and decile of 5. So are the medians. Okay, so we have already discussed the formula for decile and percentile for calculating individual series or discrete series. So we solve the problems related to Kelly's coefficient of Skewness. So this is the third formula. That means we take one problem related to Kelly's coefficient of skewness. Note down. For the given data, calculate the Kelly's coefficient of skewness. Kelly's coefficient of skewness. That means you can use any of our formula. So the value of x given as 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5 and 8, and corresponding frequency 10, 18, 22, 25, 40, 15, 10, 8 and 7. So calculate Kelly's coefficient of skewness. Okay, so try to solve this. Note down the problem. We will discuss in next class. Next class we also discuss with the help of movements how to calculate the skewness. Then we will move to the kurtosis. So in next lecture we try to cover both movements and kurtosis. So thank you, students. Now you can leave the session. Welcome to all.